Whew, these questions are getting to me. Holy smokes, I don't know about you, but wow, we got some work to do in this one. Check this one out. It says find the term that contains n equals to n to the power 8. So this looks very similar to what we were doing before. The only problem is check this out. You don't have another n in this term. The only n you have is in this term. So that means the terms aren't going to cancel out. So you can't use the entire formula and let that equal to 0 like we did before. This is a variation of that formula that we used before. Remember the formula? Yeah, that's this guy right here. Boom. There it is. Okay, so how do you go about challenging yourself with this particular question? Well, you got to realize a few things. Look at this. Isn't this n the second term? Yeah. So what does that mean? So you're going to have some sort of combination times your first term to whatever power that is, times your second term, which has to be, guess what? Negative n to the power of 8. Guess what? Huh. Look at that. It's sitting right there. There's your k value. Oh my goodness. So what's the n value? Oh, the n value is 12. So isn't this now 12? Choose 8. Yes, yes it is. Okay, it's 12, choose 8. Then what's your first term? That's 3, right? According to this formula right here, that would be 3. That would be 12 minus 8, right? And the next one would be negative 8 or negative n to the power of 8. Oh my goodness. You mean it's that simple? Yeah. Yeah, that's simple. Yeah, that's pretty easy. Okay. 12 choose 8 works out to be 495. 3 to the 12 minus 8 is 3 to the power of 4. This is going to be negative n to the power of 8, which is going to be n to the 8. All you got to do is multiply all this nonsense together. This is 495 times 81 times n to the 8, which works out to be 40095 n to the 8. There's how you do that one. Again, watch out. Look for the difference. The biggest difference is that the n is only in one term, and being that this n is the second term, they tell you what the k value is. Okay, so let's do the next question, which is example 9, which is kind of the same thing. Now, I'm just going to pick up the formula now, and I'm going to bring that formula down again. All right? Boom. There you go. Now, here's the interesting thing about this one. This one says, okay, one of the terms in the expansion of that is this. So look, I've given you the term to be x to the power 4. So how do we get x to the power 4 when that's x squared and that's 8? That's the question, right? So being that this is our first term, we can use this section of the formula. Oh, so we're getting pretty darn specific here. Yes, we are. So in other words, this is x squared to the power of n minus k, right? And that has to equal to whatever that number is. I don't care about the number right now. I'm just looking at the exponents. I know that that has to equal to x to the 4. So if you think about it, what you have to do here is you're just looking at the exponents again. You're just looking at the exponents here. 2n minus k has to equal to 4. But wait, we know what n is. N is right there. It's 8. So this is like saying 8 minus k equals to 4. Well, simplifying that is actually fairly straightforward. You can either distribute or you can divide out by 2 right now and say 8 minus k equals to 2. It's dividing both sides by 2 right there. Okay? Bring the 8 over, you got minus k equals to minus 6. So guess what? K equals to 6, making life so much easier once you find that k value, right? Now we can find that term, right? Determine the numerical value of a is what we're after here. So here we go. Let's clean this up so we can see what we're working with again, which is this mess. In other words, I want to know what is a. Well, I'm still going to use this formula because now that I've got n, now that I've got k, I know what know what the x value is, I know what the y value is, just substitute it all in there. Okay, think about this. This is n, choose k. Well, n is 8, so this is going to be 8. Choose k, we figured out to be 6. So 8 choose 6. This is going to be the x value, this guy right here. So x squared to the power of, think about it, 8 minus 6, which is going to be 4, right? Okay? Now, the cool thing about this, or 8 minus 6 is going to be 4. It's going to be 2. 2. Okay? Now, look at this. I've got a y value, which I know my y value, according to this mess over here, is that a that I'm looking for. That's going to be a to whatever the k value is. The k value is 6. All of this is going to equal to, oh my goodness, this looks horrible. 114,688x to the 4, right? Whew. Okay, it's not that bad. Start throwing in the numbers. 8 choose 6 is 28. X squared, there's that x to the 4 that I made a mistake saying earlier. I was one step ahead of myself. 8 to the 6 is here. This is going to equal to 114,688x to the 4 from our question. Oh, do you see what I see? X to the 4 and x to the 4 cancel. They're gone. That makes it a little bit simpler. So you're dealing with 28, a to the 6, 114,688. Well, now it's just solving. Divide this by 28. Divide this by 28. That cancels out, giving you a to the 6, works out to actually to be equal to 4096. Now, 6th root, yes, it is a function on your calculator. I can show you where that is right now. 6th root of 4096. Let's go into a calculator. Let me show you. The 6th root, so punch in 6, go to math, hit 5, because that's this guy right here. That allows you to determine any root in the world. Hit 5, 6th root of 4096, 4096. Find out what that is. Ah, it's 4. So guess what? Your a value equals to 4. So in your equation, way back up here, this a value is actually 4. Ta-da! That's how you do this question. Kind of complicated, but once you see it, now you know the ins and outs of this general term formula. It's not that bad.